to lesson 5 of the rivers topic. This is the landforms in the lower course. So we've explored the upper course and the middle course. Now we've arrived at the sea, at the mouth, and we're going to look at what happens in the lower course. Please copy the title and get those keywords into your glossary. Now look, this lesson is an exciting one because, wait for it, it's going to feature a unicorn and a toy boat. What's really exciting for me is that I think this is the first time ever that a geography lesson has featured a unicorn, not just any unicorn, but a unicorn that was supposed to be a rubber duck. If you're confused, then keep watching. Thanks. So we started our journey in the upper course of the river, where we found V-shaped valleys and gorges and interlocking spurs. The river at that point was narrow and shallow. And then we arrived in the middle course last lesson, where the river gets wider. We start to see meanders forming, the river cliffs and the slip-off slopes of a meander. And of course we learned about oxbow lakes. Now this lesson we're going to explore the final course of the river, where the river gets even wider and deeper and it meets the sea at the mouth. So if in the upper course we saw erosion of the river bed and mass movement and so on, in the middle course we then encountered more erosion, but more lateral erosion of the river banks, and then we also came across deposition. Now as we go on down the river is now full of eroded material, and what we need to understand is the processes of transportation, how it gets carried. So listen carefully. The first one is called traction. Now this is where, as you can see in the animation, large stones are rolled or dragged along the river bed. The second one is called saltation. This is where smaller stones bounce or skip along the river bed. The third one is called suspension. So this is when eroded sediment and very fine sediment called silt gets carried along in the current of the water. The final one is called solution, very similar to the erosive process. Solution is where dissolved material, dissolved sediment is carried along in the water. So please can you draw for yourself 4 boxes, and I want you to draw a sketch for each and a really short description. So you've got the 4 types of transportation. Please draw a sketch and annotate it. If you need to go back to listen to my explanation, please do so. Pause the video now. So here's what you could have put for traction. Large boulders and rocks are rolled or dragged along the riverbed. Saltation was when pebbles bounce or skip along the riverbed. Suspension is when light material or light sediment is carried along by the river. And this is the important bit, is when minerals are dissolved or sediment is dissolved in the water, and it gets carried in the current, carried in the river. To understand the formation of a levee in a floodplain, I would like you to imagine that the river is a bathtub. In your bathtub you have Exhibit A, the unicorn. This is our alluvium, the very light fine sediment. Okay? Then we have Exhibit B, the toy boat. This is our large stone. Now what happens is your friend calls. You haven't spoken to your friend in a long time, and you get chatting and you keep talking and you forget that the bath is running. The bath starts filling up, and then you come back to it 20 minutes later and our unicorn and the toy boat are all the way up here on the bank of the river. Then what happens is the river bursts its banks. So what happens next? Where does the unicorn end up? Does the unicorn stay on the bank of the river, or does it end up by the door? Similarly, what about this heavy toy boat? Does that stay there, just sit on the bank of the river, or does it move?
So that tells the story. We end up with a unicorn, our alluvium, all the way over here, which has been transported in suspension as the river has flowed out across the land. There's our floodplain there, covered in alluvium. And here we have the formation of a levee where the larger stones have been deposited along the river bank, and it gets built up over time after successive floods.
Please get your page to look like this. You need 3 boxes, and so draw your 3 boxes. They don't need to be that big, and write formation of a levee and floodplain. Now, levee and floodplain, there are 2 different distinct features, but they're both formed at the same time when a river is in flood. Okay, so the first box we're going to annotate. I'll walk you through it. First thing that happens is our river floods. Remember the bathtub overflowing. That's the first step. Next up was the alluvium, that very fine sediment, silt if you will, that gets transported across the land. That was our unicorn that ended up by the door. So this is the alluvium. It gets transported in suspension because it's light, and then it gets deposited on the land. Okay, this forms our floodplain. Then the final stage, this was our toy boat, which was reasonably heavy. The larger sediments, the larger stones, they get deposited on the edges of the riverbank and build it up over time. So what you can actually see is that the banks get built up over time, and that we call that the levee, and it builds up over a course of many floods, and actually can help to stop floods in the future. Okay, so it's a bit strange. It's caused by a flood, but it can help prevent floods as well. Please make sure your diagrams look like this, and then we're going to write this question up. So we're going to explain the formation, which means how is it made, of a levee and a floodplain. Now, if you remember, we did them kind of back to front. We did the floodplain first, and then we did the levee second, but that doesn't matter too much. Use your diagrams, okay? It's a 4-mark question. We're going to start with firstly, as we always do, and we're going to get things in the right order. Firstly, here's going to be our first mark. Firstly, what happens? The river floods. Do the rest yourself, pause the video, and we'll do the answers shortly. Okay, answers here. So firstly, the river floods, like we said, tick. We've got it, and then we say because alluvium is lighter, it gets transported in suspension. The important bit, guys, alluvium gets transported, we get a mark for that, before being deposited across the land, forming a floodplain. There's a lot in there. Maybe in an ideal world it could be a 6-mark question, but let's just make sure we've got all those things in there. The next bit, larger sediments are deposited on the edges, on the banks, forming a levee. So actually we had 1 mark for the first box, we had 2 marks for the second box, and we had a final mark for the third box. Give yourselves a mark out of 4 and green pen anything that you didn't include. This photo shows a delta. This is our final landform of the lower course we're going to look at. Now this is when the river meets the sea at the mouth. The energy of the river really slows down because suddenly it meets the sea and the sea starts pushing back up the river. So we have a huge amount of deposition going on here. This is another one from space. This is actually the mouth of the Amazon River, and it shows a delta. Now a delta is made up from something called distributaries. Now distributaries are areas of land that have been deposited in the mouth of the river as it flows out to sea. Okay, so these are called distributaries. And it's really straightforward. It's the water slows down, and because the river's carrying so much, but it's got so little energy, it has to deposit all the material. Think of it like an elderly person walking with their shopping bags to the bus stop. They're getting increasingly tired. The bags are getting what feel like increasingly heavy. Eventually they have to stop and they have to deposit the bags on the ground. Exactly the same thing happens here. Here's another great example. You can see that the river, which is now almost a kind of brown color, okay, because it's carrying so much sediment, has flowed out to sea. It's run out of energy as the sea is pushing back up into the mouth. And then we have all these distributaries being formed here. So for this, we need a really straightforward, simple diagram, just two boxes. They can look something like that. So what we have in the first one, annotate please, is that at the mouth or the estuary, the river loses its energy and we have deposition of sediment. As the sediment is deposited, we have the formation of distributaries. So that is all you need there. Please pause and get those diagrams copied down. Let's take a look at the formation of a delta in the river Amazon, the world's largest river. So here we're now looking at the lower course of the river Amazon as it flows out towards the Atlantic Ocean. Here's the mouth, and quite clearly you can see all this deposited material. The color of the water is brown because it's carrying so much silt and sediment and eroded material. And here you can quite clearly see these kind of islands, which are the distributaries. This whole area is huge. It's some 100 kilometers wide, and these islands are large islands in their own right. Next, we'll look at the River Nile Delta, which is different to the River Amazon Delta. The River Nile Delta is much more well established, I suppose, and it's actually the distributaries have all joined up over time. Now you can see here, this is the River Nile from the south, and it flows essentially through desert. And without the process of... Next, we'll look at the River Nile Delta, which is different to the River Amazon Delta. The River Nile Delta is much more well established, I suppose, and it's actually the distributaries have all joined up over time. Now you can see here, this is the River Nile from the south, and it flows essentially through desert. And without the process of flooding and... So with that in mind, we can now explain the formation of a delta. This is really straightforward. It can only ever be a 3-mark question because there's just not enough to say. So we need to say something about what the river does, and we're going to start here. So we say, firstly, as before, use what we've got there, then talk about what happens here, say why that happens, so why does deposition happen, and then lastly, the feature formed, which is basically the delta. Pause the video, give it a go. And the answer is, firstly, the river flows into the sea at the mouth estuary. We've got the word firstly in there. Next, it loses energy. That explains why this happens. It loses energy. The elderly person at the bus stop drops off the bags. Deposit sediment onto the seabed. Here's the important bit. This forms land called distributaries, and all of the distributaries together are called a delta. Mark it and green pen what you didn't get correct. Quick challenge here. Identify the two features labeled Y and X. Pause the video. X was a levee right on the edge, the river bank, and Y was the large area to the sides of the river that was the floodplain. Try this one. Identify the two features labeled X and Y. X were the distributaries, those islands, okay? Here we're looking at the mouth of the Amazon River. And then Y was the river mouth. I think we could have maybe accepted estuary, possibly. To finish the lesson off, please pause the video and answer these consolidate questions. Now check and correct your answers. And next lesson, we're looking at storm hydrographs. After that, we're going to look at a case study called the River Eden in Cumbria. And then we're going to look again at river flood management, just as we did with coasts. I'll see you then.